In this video, I want to go over mathematical modeling using Excel. So we're going to start with a data table like this one. This data table represents the number of bags in a box and the total mass. So what we need to do is, after we get our data table, put in, I want to remind you here, the first column should be the x-axis and the second column should be the y-axis. This is what Excel is expecting. So what I'm going to do is select this data table. I'm going to go to the bar at the top and choose Insert. I'm going to find the Chart, Insert Chart buttons, and I'm going to point at the one that has a scatter plot. Click on that and choose the first option. You can see it pops up what it's going to look like, and that's exactly what I'm looking for. Okay. So once you get your scatter plot, one of the things I want to point out is if you want to add labels, titles, change axes and stuff like that, click on the little plus here for chart elements, and you can go in and open those things up and change them. That's not important right now, but on the assignments I'll give you, I have expectations for the chart titles and that sort of thing. Okay, so what we really want to look at right now is adding a trend line. That's what we want to do. So if I point at one of the data points and then right click, it'll pop up this little menu, and the one I'm interested in is add trend line, and it throws a trend line in there. The ones we'll be using in engineering this year are primarily linear, but you have other choices here you could apply. Really, if you're not sure which one to use, turn on your R-square value and look for the one that has the best fit. Notice right here there is I'm not going to talk about that right now. What we're going to put in right now is the equation and the R-square value. And when you display those, it describes the line of best fit that is put in. Okay. Once you've got that done, you can close the little side menu. And just for our convenience here, I'm going to make this much larger so that it's easy to read. Alright, so here is our formula and our R-square value. Remember your linear formula, y equals mx plus b, where m is the slope and b is the y-intercept. And if you look at this line, it would intercept at about 20, which is 19.3. In this case, that represents the mass of the crate that we're putting the boxes or the bags in. And then if you look at the slope right here, the dotted line, the slope of this dotted line is 14.7, and that is the average weight of a single bag of flour in our problem here. So that's how to interpret that. It's unlike math, in engineering, these numbers have a meaning. Also, I want to talk about the R-square value. Technically, it's known as the coefficient of correlation, and all I want you to do in this class is, while that's important what it is, I want you to understand how to use it. Think about it like a score. 1 is perfect, and if your data set is 1, you'll have all your data points on this line. But you can see that they're not all on the line, but they're really close. So look at the next two numbers like a score. So if you made a 98% on a test, you'd be pretty happy. So when you see a 98 there, that tells you this line really accurately describes the data set. If it were if it's 0.8, you need to start asking questions about how you do your data collection, and is there some sort of mistake that you're making, or are you using the right tool to collect your measurements? If it's below 0.8, so if it's 0.7, 0.6, you really probably shouldn't use this as a way to predict what's going to happen unless you absolutely have to. So that's just a little bit about how to put in a scatter plot and apply a trend line with the formula and the coefficient of correlation. Thank you so much.